So good afternoon, everybody. This is your second day, so I'll try to keep you guys awake. I'll spare you the heroic story from Moscow airport this morning, and I'll just step into business. So a few words about myself. I'm dealing with data for the past 14 years, I think. Stepped into the games role somewhere in 2010. I led the business intelligence unit for Bwin, and a few years later I led all the data unit for Politica. I've been an entrepreneur for the past 3 years, and for the past year I'm the CEO and co-founder of Simpool. Simpool is a lifetime value optimization and prediction system, which mostly based on game simulation, and specifically on everything related to game economy. And today, I came here to talk about simulations and the impact on LTV. So I want to start my first the presentation with this really magical moment, which we, as game developers, all strive to achieve for our players. This very excitement moment. But as you probably know, this excitement was not only achieved by the nice colors or the shiny cha-ching sound. It was all a result of a well-thought-out game economy behind the scene. Many things was perfectly tailored and engineered for this user. And this is one of the things that mostly differentiate between the big companies who succeed and unfortunately for many companies who don't. And we talk about game economy, we're talking about a fight for balance. It's a balance between earning and spending, between winning and losing, between free-to-play time and pay-to-play time, and mostly for users, balance between frustration and satisfaction. And the thing is that we are facing this battle almost every day in this industry. Every time we want to change something on a live and kicking game, every time we want to add a new feature, every time we're planning a new promotion and we want to create some kind of artificial inflation, but we have to understand what is going to be the effect a few days after. And actually, every time there is something that goes in real time and we have to take a decision, while there are so many options to take. The way that we're dealing with this today is, for example, if we want to make a change on our 30 days lifetime value, we will probably make an A/B test and we will have to wait 30 days. We'll have to purchase a significant amount of users and pay a lot of money to get this significant result, but it's going to cost us. And most of the cases, when we'll take a decision and we'll implement some kind of a game configuration, it will be some kind of a guesstimating. All right? So for those of you who not that familiar with a game economy, mostly it's not so easy to implement. Think about huge Excel files with maybe thousands or 10,000s of rows, probably dozens of different columns, tens of thousands of parameters, but it's kind of reflect a linear or rigid approach, while we as people, we're different. People, users, play the game differently, they consume the economy differently. We have the payers, we have the non-payers, we have the whales, the sharks, the dolphins. We have social users who like to interact with social network, they like to collect all kind of gifts. But on the other hand, we have the anonymous. All of us behave differently. All right? So let's talk how it's reflect on our calculation for lifetime value. So in its pure calculation, lifetime value built from the way we monetize and the way that we are return our users, the way we are pulling them back to the game and how attractive it is. When we're talking about user acquisition, there's also the viral effect, who in most cases help us to decrease the relative cost per user, what we call effective CPI. So lifetime value is a subset of predictive analytics. It helps us to take better decision if we know what would be the expected revenue from our users. But most of all, it's an effect. It's not a cause. If we'll create a good game, we will be benefiting from good performance, and it's all translate to this term ROI, return on investment. Okay, so there are a few major approach to calculate lifetime value. The most common one in our world is the probabilistic approach, which relies mostly on monetization aspect. There is a famous prediction model called RFM, recency, frequency, and monetary. There is also another significant approach which reflect a regression and curve, which mostly touch correlation between different variables. I would like to give you a small example, which is also something that we're doing in Simpool. We're using this simple formula, lifetime value equals to APDs, actual playing days, multiplied by the average revenue per daily active users. The way to calculate APDs is using this retention curve. I'm sure you're all familiar with this formula, but calculating the integral below the line will give us these results. Let's assume ARPDAU of 20 cents. Let's create a calculation, and we know that the lifetime value will be $3. Let's take another assumption that we are acquiring user for $5. Let's assume the organic lift will be 20%. CPI will be $5, which reflects only 60%. And if we go to eCPI, then we'll have only we're increasing the return on investment for 75%. Now, let's understand that we have a gap and we want to make a fix. I talked to you before about what happened when we want to make a change in the game. Now let's talk about how we can make it easier while using game simulation. So when we're talking about simulation, the definition of simulation is the imitation of real-world process or system over time. There are many approaches of how to run simulations in our world, and I want to take you to a journey of some of them. So let's take for the flow that the way we defined a simulation. First, we need to define the core game loop that we're actually developing. This is the most pure set of actions that users are doing in the game that we're developing. It can be shooting, racing a car, make a spin, or even play a board. Then we need to define what we want to achieve through this simulation. Do we want to evaluate the user balance, the currency on a certain point of time, on a specific point in the game? Do we want to predict the lifetime value at the end of this simulation? Do we want to predict retention? The next step will be we need to list all the actions that users can do inside a game. They can log in, they can use a booster, they can create an attack, they can repair their car, they can go to the shop, they can do a set of actions that will be listed inside our simulation. We need to have a very clear list of all the resources that users can use to collect currency inside a game, either by winning, losing, go to the shop, ask a gift from a friend, all kind of actions that we can find inside a game. We need to list the resources and the sink. They have to be coordinated in order to make sure that we're not creating any kind of inflation. And then we need to build the logic. This logic and structure means what happened if users doing X, what will happen if users will do Y, how can we adjust between different profiles inside the simulation. And then we need to define what are the variables, what can be unexpected in the simulation. It can be things that we know, users more active during specific hours on the day. Users might purchase more aggressively at the beginning of the month because they just get their paycheck. Users are more active through specific platforms and things like that. And also there are a lot of unknown variables inside the system. This is where we're using a simulation algorithm called MCMC, a Monte Carlo Markov chain. I won't go into this at this moment, but if anyone is curious, we can talk about this later. The next step will be to balance the system. We're taking the system and monitoring the system all over the simulation to understand how the users progress within this ecosystem. And at the end, going back to what we defined on the second step, let's see if what we wanted to evaluate it is actually what we were able to achieve through the end of the simulation. Basically, I want to make it more simplified, we have all the integration phase. When we collect the data, we define the structure, we create the segment, we run the simulation, we learn the insights, and with today's technology of machine learning, we are able to give orders to the machine to learn and adjust itself. Bear in mind that we are, as the game developers, when we need to take a decision and we are a group of people, we can share few opinions, raise few ideas, the benefit of the machine that it can run these options hundreds of thousands of times. Okay? One of the basic elements that we use in the algorithm is a three-dimensional progress. Bear in mind that users can progress in each one of them. User can progress in its monetization aspects, in its LTV. It can progress in time, how much time and how good we are retaining users, and how far they are progressing inside a game. Looking on the output, this is the output of a Monte Carlo simulation. This is just a predefined set of users. Each line represents a user. We took a path of hundreds of thousands of users, and the x-axis is the number of actions that users could have been taking inside a game. And at the end, we took an average or using median to understand where will be our choking point. Choking point, I mean, where do we want to convert the users for the first time? Bear in mind that the game, since the game contains so many aspects and so many metrics, what is the welcome gift? How many swords a user should receive on his first day in the app? How many swords should we give him on the second day gift? What happened if the user level up? How much swords or shields or fuel or coins we need to give them for any actions? This is the output of what we're seeing here. At the end, when we are taking this approach, we don't need to wait. We don't need to wait 30 or 60 days if we want to see an improvement for the next 30 days. We can have a very good ballpark and education about the result. We don't need to spend huge media budget. The whole idea of simulation is that we can get statistical significant result by simulate millions of users, and we can do it for any kind of variation in the game that we want. And most of all, we don't need to guesstimate. All right? The end result, again, is more moments like this. When users are looking like this, it means that they will retain, and not less important, they will be monetized. All right? Thank you very much. I hope I didn't exhaust you too much, and I hope you find it interesting.